So hi everybody, I'm Alex. This talk is Beyond MVC. So sort of a tiny bit of background and context for where I'm coming from when I give this talk. I am most involved in sort of the Python and Django communities, so those are what the sort of tools that the examples will use. I think what I'm going to say is kind of applicable to people regardless of what tooling you're using, sort of as long as you're doing back-end stuff. I spent the first couple of years of my career mostly working as a contractor, so tons of different projects, and then moving to working for companies that were building out their own things, so you know, one project at a time. So show of hands, who here writes computer programs? Probably everybody, cool. Who here writes network applications? Couple hands. Who here writes web applications? All the hands. Who here writes web applications with an MVC framework? Cool, that's like all the hands. Great, you're in the right place. Except the hands don't make sense to me. Because when I think about what is a web application, the thing I think is a web application is a subset of a network application to me. A web application it's got a pretty well-defined protocol, always talking on port 80, HTTP, all that good stuff. But it sits in that, and the specialties that a web application developer should have, to me, seems like it should be a subset of a network application programmer. But across the board, everyone I talk to, nobody who identifies as a web application programmer also identifies as a network application programmer. And that was interesting to me, and that's kind of what got me started thinking on what became this talk. So when I look at sort of the last decade of web development, they've, for me, been strongly marked by frameworks like Rails and Django, which kind of changed how people build websites in a really, to me, interesting way. I went back and watched a bunch of videos people give talking about Rails and Django in like 2005, 2006, right after they came out. It was really cool because every talk I saw, somebody mentioned the phrase database-driven web applications. And now, probably no one will use that phrase all day. It's just a given. These frameworks have allowed us to handle, with surprising grace, the incredible increase in complexity of the applications we're trying to build. Back then, you know, it was impressive that you got a template tied up to something in your database and like were able to show data. That was, you know, far surpassing expectations. But as our keynote this morning talked about, the expectations have changed and we're looking for more. And I'm personally finding the patterns we use with these MVC frameworks to be a little bit wanting. And I've said MVC a whole bunch, but in truth, it's a bit of a misnomer. The term MVC, as we use it today with frameworks like Rails and Django, doesn't really match the original intent of the term in kind of an interesting way. So the term comes out of like the 70s, and specifically GUI applications, so like running on the user interface of the day. And for a variety of reasons, it doesn't actually match up well with what we do with web applications. So Django is actually, interestingly, never claimed to be an MVC framework. It just sort of came out as that term was becoming popular for web apps, and it stuck. Django's always identified as being an MTV framework, model template view, which is a slightly different take, but substantively the same. Sort of the interesting way that these frameworks are not like MVC frameworks for GUI applications is that the core idea for model view controller for GUIs was the dispatch. That something changes in the user interface and we need to reflect it in the local data. Something changes in the local data, we need to instantly reflect that back to the into the user interface. This doesn't totally match what we've been doing with web apps for the last 10 years because we're sort of been bound by this request-response cycle. What the interface of our apps was really controlled by the browser's opinion about how you should access what were originally thought of as just being documents, not even being applications. So that mismatch has made it a little interesting. There really, until recently, was just not the technology to do two-way back and forth between a browser and an application on the server side in any sort of real-time fashion. You had to stop what you were doing and reload the whole page until just a few years ago if you wanted to change anything about it. And so it's a bit of a mismatched term, but I'm going to run with it, even though the only people who write real MVC applications these days are pretty much iPhone programmers. So if MVC is not the right term, I kind of want to lay the blame for what I'm going to talk about at sort of full stack frameworks, ones that sort of offer us many of the conveniences that we need to build tools of these complexities. So that's spending our first 6 months, picking out everything in our stack and rebuilding everything from scratch. So I like to look at what's in a framework. What comes out of the box with a lot of these frameworks? What functionalities it say it's handling for us? And it handles a lot of stuff for us. We have this request response abstraction. We don't handle HTTP requests natively. In fact, we don't even really handle HTTP requests as our languages expose them to us. Rails provides a higher abstraction of a rack. Django is a higher abstraction of a WSGI. Almost every one of these frameworks takes sort of the lowest common denominator that these languages offer and says, this is insufficient. We need a little more structure. We need a little more tooling around this to make it convenient to work with. They also tend to offer a command line interface for running administrative tasks, database migrations, all that kind of stuff. And then a whole bunch of libraries with varying degrees of integration into what we're doing that are useful for building websites. We have ORMs and other database bindings, templating language, internationalization, sessions, cookies, all these sort of utilities that we can bind together, and they have varying degrees of integration. The ORM tends not to know about the sessions layer, but sometimes the internationalization gets into the templates, and sort of the more integrated these components tend to be, the more we might be inclined to say this is a full stack framework because everything works together. But more than that, frameworks like Rails and Django seem to provide an environment. You would never say, oh, I'm a requests programmer. Requests is a popular Python HTTP library. You would never identify yourself as, oh, I'm a programmer of this library for making HTTP requests. We totally identify as members of a community that responds to these HTTP requests. Yeah, I'm a Django programmer. I'm a Rails programmer. Those are ways we label ourselves. And this manifests a lot in the way we talk about solving problems with these frameworks. So there's sort of two forms of a question that seem pretty similar. How do I do X in Django? How do I respond to forum requests? How do I show this analytics chart on the front end? Or does Django have something for doing X? Does Django have something for working with forms? Does Django have something for working with charting in this particular way? And the questions at first might seem similar. You're trying to get at information about how to perform a task. How do I do this? But in truth, when I look at the split, I hear the first form of the question, how do I do X in Django, far more often than does Django have something for X? And of course, the answer to how do I do X in Django is the same way as you would anywhere else. Import like the most raw database bindings and write a SQL query. Parse the HTTP post body yourself if you feel so inclined. Write some HTML and write some JavaScript. Django does not have special magic, and almost none of these frameworks do. They always let you just drop down and just write some HTML. Just run a SQL query. Like none of these tools prevent you from accessing the rest of the libraries available in these languages. A lot of times they provide helpers, simplify things. It's a lot easier to write that SQL query if you know your way around the ORM. But you can always solve the problem in sort of the raw way. And I think the way we mentally put together our questions as how do I do X with the framework is limiting because we're thinking of these things too strictly as an environment that we program within and that dictates to us. More of a straitjacket than a toolbox, which has a whole bunch of utilities for working with. For a variety of reasons, I think this is starting to change, and the way we use web applications is starting to change, because the previous paradigm, where sort of the way HTTP as a network protocol worked dictated what the user experience of our websites was, that is starting to fade away as this protocol changes to accommodate a different type of user experience. No more documents where you reload the entire page to get something new, or even where parts of the page reload. Now we have expectations for a lot of different types of websites that they will live update for us as things change on the server side, that lots of the rendering will be done on the client side to accommodate all sorts of different things, like knowing what your browser's localization is, even if it doesn't send the right headers to the server. All this kind of stuff is starting to change as clients get smarter and are no longer just web browsers. Now we're far more dictating to programmatic AJAX requests, SDKs that are also accessing these same APIs. We're catering to fundamentally a different client, and that client is not the web browser of 5 or 10 years ago. So as a result, we've seen the rise on MVC on the client side with a lot of different frameworks. I'm not going to really talk about that because I am not really a front-end developer in any meaningful sense. But these are adopting naturally a lot of the same patterns as Smalltalk programmers in the 70s and iPhone programmers now, right? They're using MVC in its more natural sense, doing that two-way data binding because it's real time and all that. So that's pretty cool. I do think it's pretty funny that we're now running something called Model View Controller on both the server side and the client side. It seems like we shouldn't need that twice, but I think this is making the client side of the browser much more real is a good thing, and like finding practices that accommodate that is super valuable. So I kind of have two principles of programming that kind of inform the recommendations I'm going to make for here on out. And they're pretty simple. There's nothing earth-shattering here. First is that writing correct code tends to be hard, really hard. In particular, it's difficult to evaluate whether code works just by looking at it. We tend to have to run it in some form or another to have any deep understanding, particularly as we get towards composing smaller things. It's easy to tell that my arithmetic addition function is correct. Maybe it's easy to tell if my factorial function is correct. It's really hard to look at my data analytics function that joins from 3 different tables and tries to compute who the most important customers based on a combination of like revenue and growth and all these other statistics I have about them. Whether that function is correct, that's a lot harder. It tends to require a lot of tuning over time, particularly when we're not looking at things that necessarily have a right answer like addition does. So to sort of combat all this complexity, and particularly the combination of complexity in we want our websites to do more, specifically we want them to do so much that I can't just test every change I make manually. I'm a big believer in automated testing, not just as like a thing you should do, but as a central design tenet. If a design of your software does not accommodate it being tested, I'm immediately suspicious because I don't know how to write code that works any other way. The other principle, and this really informs the first, is that reading and reasoning about code is hard. Specifically, like, again, the bigger the piece of code I have to reason about all at once, the harder it is. So I want to prefer designs which have smaller components that I can reason about individually. The more code I have to keep in my head, the more that inevitably leaks out that I can't follow along. And so I try to think in terms of pure functions where I can know what all the inputs are to them just by looking at it. There's no inputs coming from somewhere else that I have to read code in some other place that's not obvious to me to understand. I tend to try to avoid code that deals with time. I think time is sort of the greatest source of bugs. Whether it's this function is only wrong when it's run in Australia during the first 6 hours of a new month. Actual bug I've seen. Used to be Django's test suite failed under those conditions. Or code that changes based on if someone else is also running the function at the same time. Sometimes these are inevitable. 2 people make 2 requests to the same server. Something's got to happen if they're accessing the same resource or trying to modify it. But I want to try to keep code that deals with the temporal aspects as isolated from other parts. Code that needs to deal with showing the logic of who's coming to my golf outing shouldn't have to worry about the difficulties in the back-end analytics that have to do with 2 people trying to update it at the same time. I want to localize the complexity. And so that sort of brings me back to the subject of MVC, and particularly MVC in practice. One of the favorite things I watch, reviewing what we were saying 10 years ago about web development is the Rails NV screencasts or videos. Does anybody remember those? There were these set of videos put together by a really early Rails consultancy, sort of marketing videos in the PC versus Mac vein. Hi, I'm Rails, hi, I'm PHP, that kind of thing. And over and over again, watching there's like 10 of these videos, the theme that the Rails programmer who sort of touting Rails is talking about is that Rails brings you a separation of concern because of its MVC. The models are separate from the templates. I don't have SQL queries coming out of my HTML anymore. The JavaScript is not randomly in some function that's supposed to be doing analytics. Separating these things out, getting better organized, no more the spaghetti and meatballs mess that I think a lot of us were accustomed to before, at least for myself, before I found these frameworks, and I started to appreciate why I should not have SQL query coming out of my HTML. But I think what these things tend to look like in practice still involves a lot of this coupling and putting things in places they don't quite belong. It's more subtle, to be sure. My CSS no longer has like Postgres commands in it. But I think it's not any less destructive, and I think we're still mixing concerns. So this is a pretty typical Django view. Django doesn't use the term view like a lot of other MVC frameworks. For us, the view is not the template. The view is the function that dispatches from a request to a response. And I think this is probably readable, even if you're not super familiar with Python or Django. Sort of to run through it, we have a request, and we have some poll ID that's extracted from the URL. And so we try to find a poll with a primary key that matches what's in the URL. And if we can't find one, we just throw a 404. Then we look for a choice on the poll. This is the voting portion of some poll application. And we try to find a choice that matches what's in the post body. And if we can't find one, if there's nothing in the post or there's no choice that matches that primary key, we just show the detail form again and an error message saying, hey, you didn't select a valid choice. Otherwise, we increment the vote count and we save it, and then we redirect back to where it came from. And this is a super typical Django view, so typical, in fact, that I took it right out of the initial tutorial. So like, it's in the tutorial, this is representative, and like I can tell you, this is representative of what stuff looks in the real world. It's in the tutorial. Clearly, we think this is something maybe people ought to be modeling their applications on. So a few things I want to highlight. We're accessing request.post here. We're taking requests as an argument. So clearly, this is executing in the context of an HTTP request. This is not a type of function we could call from some back-end batch processing job, or if our voting thing grows like an IRC interface or a Slack interface. We can't access we're executing in the context of HTTP. We're reading stuff out of the post body. Makes sense. We've got a couple other things. We're doing some database lookups. We've got this getObject or 404 function, which does this sort of bridging, this integration that we might expect, where we're using the database and caring about HTTP at the same time, mapping non-existence of resources to 404s. Cool. P.choiceSet is doing a related join and looking that up in a different table. Cool. We got a lot of database-driven web applications. Web apps need databases. Cool. Makes sense. We're changing our object. We're saving it back. Incrementing the vote count. It's a little trivial, or like not preventing double votes. Any of that cool stuff. Again, pretty normal stuff. This looks like, if your web apps are anything like mine, stuff we've probably seen a lot over and over again. We wouldn't give this a second look. Except I want to seriously ask the question, why does this view do so much stuff? And to really hone in, why is the protocol logic mixed up with the business logic? When I think about sort of what is a core tenet of modularizing my components and sort of separation of concerns, it has to be that the logic of my business is not mixed up with the logic of my persistence or the logic of the protocol it's accessed over. So I've got this rule that functions may either implement business logic or they may touch the request object, and they may absolutely never do both at the same time. So why not both? It makes things much harder to test, for one. When you need to have a full HTTP request in order to check that your database logic is correct, it becomes a lot. Just writing out a test for your business logic becomes a lot more expensive. On the flip side, more expensive in time it takes to write. On the flip side, now testing your protocol logic requires setting up a whole database, and all that becomes much slower to execute. And fast tests are really important to me because the slower your tests are, the slower you can iterate. So that's all important. The other thing is that this unnecessary coupling stymies you in the future. What happens when you decide your poll app needs a new mobile application and you need an API in addition to the API version? You can't reuse this business logic without extracting it. What happens when you want to write a command line admin tool to make things easier to administrate, you got to duplicate the logic because it's trapped in this HTTP world. What happens when your company pivots, God forbid, into IRC-based polling, and suddenly you need to expose this to somebody who's coming in over a chat request? Sounds like a joke, but I have worked on apps where we suddenly needed to move logic from an HTTP layer to an IRC layer. But regardless, splitting the HTTP handling code from the business code, to me, just comes back to what is the essence of separations of concerns. But truthfully, in what I see in real applications sort of across the framework board, mixing these two up seems to be sort of just a thing that everyone does and takes for granted. Sort of the essence of embodying this is that we tend to use the ORM everywhere. Not quite as bad as, I've got how did you get your SQL in my CSS, but we tend to be anywhere we're writing Python code, we're comfortable importing the ORM and starting to make requests. When I think about how I design this from scratch, I always tend to want to come back to, I want to have some sort of wrapper around my database access. Not because I necessarily care about being able to switch out my database. In practical terms, you can't just swap out your Postgres or your MySQL for Cassandra or some other totally different database. I'm not concerned about that type of abstraction where I want to be able to switch it out. I'm concerned about being able to reason. I want to be able to reason about a semantic operation, add new vote, and not one that's based on the implementation details of how do I update a vote in Postgres. And I'm one layer removed, right? I didn't write SQL. Nothing I wrote was Postgres specific in that view. But I'm still very much connected in that I'm tied to what is this database's model of concurrency. What happens when I go change that code to handle multiple people trying to update the votes at once? Suddenly, this code that's tied to HTTP is now also tied to the transactional semantics of my database, and that doesn't seem right. I want to have a separation of the semantics of my application from the implementation of them. What are the business rules and how are they implemented? Should be separate things. Sort of the most fundamental way this manifests itself, I think this confusion is I see this question a little less now, but it used to be I could sport a solid Stack Overflow score just by answering this question over again. How do I get the current user in the save method of my model? I used to sort of try to walk people through why the HTTP layer is separate from the database layer. Now my response is, what is the current user? Why would your persistence layer know about the user attribute on this object name request somewhere else, right? These are conceptually, I think, very different things, and we're not modeling this well enough a lot to new users, so there's this confusion. So we've got this confusion. I hope I've convinced you there's something suboptimal about the way we're organizing. What is the alternative? We've been doing this for a couple of years. It seems to be preferable to at least where we came from. So where do I think we're going? I think full-stack MVC frameworks, to me, very clearly have left something to be desired, or at the very minimum, the way we use them. It's not necessarily inherent in Django that your model always is touched in the HTTP request handling function, but it is endemic. What's the alternative? Going minimalistic, using Sinatra or Flask or some other framework that just doesn't have all these components? I think my experience working with micro frameworks has been that they don't escape these issues either. We reinvent the patterns of the larger frameworks in them. If the pattern that means separation of concerns is failing at separating our concerns, how could we succeed? And so here are a few ideas about how we can get better at actually really separating our concerns. The core idea for me is to develop abstractions around semantics. For some reason, it's really common to want everything to fit into a Django-provided abstraction. So Django has models and forms and template tags and template context processors and model managers and a few other things, migrations. And so these are sort of abstractions provided for us by the framework. But that's not how we develop software in any other place, right? We don't develop just software that there's an existing abstraction before. complex problems require that we develop abstractions which match that challenge, and specifically we come to domain-specific abstractions. We're not concerned with platform details, Windows versus POSIX, MySQL versus Postgres. We want to think about removing the person who is dealing with implementing the business logic from dealing with the persistence layer, or the person who's writing the web interface to be separated from the actual business logic of their operations. We're a little better now than we used to be, right? I can write a template purely based on the data provided to it without needing to know where that data came from. But we're not quite at the point of not needing to know where the data came from in order to map request.post subchoice to getting the right post object, or to getting the right choice object. We're still very much concerned at the same time with the business logic of finding the appropriate choice and voting on it at the same time as we're concerned with where does my choice's ID come from in the request. And of course, these abstractions are not at all mutually exclusive with things like ORMs that abstract which database library we're using, or anything like that. They, in fact, synergize incredibly well. My ORM provides me an abstraction away from SQL, away from being MySQL or Oracle specific. And then my domain-specific abstractions provide me a way of reasoning about vote on this choice without worrying about, the ORM's concerns of which database I'm using, but also removing me from where in the request of these things come from. And so this is a pattern I've been following with a couple of the more recent applications I built, and I've had a lot of good success with it, particularly around being able to test things and swapping out components within the context of my tests. So that's been it's been for me a great win in terms of achieving the goals of really being able to reason about less code at a single time. I still have the same amount of code overall. I might even have a little bit more code now that I'm writing a whole lot more functions to deal with these things. But I need to read less code at any given time. And so that's been a win. There are a few disadvantages. Sort of talked about the good sides of this. There are some definite downsides, though, that I would be remiss if I didn't mention. There's a small hit in development speed, particularly right at the beginning of the project. I spend a lot more time trying to map out what are my business rules, what are the business operations that occur here. It's easy when you've got a polling site with one operation, vote. It's a lot harder when the operation you're trying to reason about is a user favorited this item, and it's got to go in all their friends' feeds and sort of all these mutually connected business concerns. So I spend a lot more time reasoning about what the core business operations are. So it's definitely a loss up front. Later, it's very helpful, I've found, and can speed things up significantly later. I now tend to have only one place to go look for, okay, how do I add something to a feed? It is my experience that when you have the pattern of just use the ORM directly everywhere, the ORM is pretty succinct. Getting a model, changing a field, and saving it back is like 3 lines of code. So the pattern tends to emerge that it doesn't get abstracted, and you might have the same 3 lines of code everywhere, and that definitely is a maintenance burden later on. The bigger concern is that there's a certain loss of consistency. This was one of Rails' big pitches early on, and Django was much in a similar vein, this convention over configuration. I recently had the experience that I went back to work on a Django website that I was involved working on something like 5 years ago, and now I need to come back and do some new work on it. It's a conference website, so now I'm involved with the conference and I need to contribute to it, where before I was a contractor working for the company that was building the website. Codebase has experienced a lot of changes, like the conference has moved city twice, all that good stuff. I immediately found myself recognizing patterns in this code that I hadn't looked at in 5 years. Oh, I know right where my models are. I know this is how the table is laid out. I know where my view function is. I know where my URL mapping is. All of this stuff was very, very natural to find, even as a code base I hadn't looked at in half a decade. Having patterns that are specific to the application you're targeting definitely is a loss of consistency in that respect. There's not necessarily, oh, this is where my models live, because models is not doesn't just map necessarily to a single business or functional concept within your application. You might have, oh, here are the operations for dealing with an album, and here are the operations for dealing with my friend feed, and all of that stuff. Views.pies, having your views when the views do almost nothing, definitely is a loss of that consistency. And you'll have to move somewhere else to find sort of the meat of the code. The advantage is hopefully each of these components will be easier to read on their own. But there's definitely a loss of, oh, I just know where to go look for that. I know this framework. And that sort of leads me to a really bizarre conclusion, which is patterns for people who write a lot of websites might be different from patterns for people who are working on just one website. It's not at all like an intuitive conclusion for me, but it seems to make sense that if I work on 20 different websites at any given time, I value the consistency above writing things that are really specific and tailored to my use case. I haven't fully wrapped my head around that conclusion because it just seems fundamentally weird that like the way I wrote websites as a contractor would be violently different from the way I write them now that I just work on one at a time. So sort of bring it all back together, the complexity of what we build and what we're expected to ship is increasing, with of course no decrease in the amount of time we get to spend on it. The way we talked about web applications a decade ago when these frameworks were all conceived is insufficient to the challenges we have now. Back then it was impressive that you managed to map what's in your database to some HTML that got shown to a user, and we just far exceeded that expectation. We met that challenge. Now we need to come to master the challenge of increasingly complex and interdependent business rules, increasing demands on the multiple different interfaces someone will access this over. It's no longer sufficient to just have a website. Now you need mobile apps on 3 different platforms, a web app that's specifically tailored to the mobile app, mobile devices in case it doesn't, in case people don't have the app. All these different demands of how people access our data, how much data there is, and the ways the data interact with each other. And these MVC frameworks and the patterns we use with them do not cope to handle this because they force us, or at least ask us, to put too much interrelated knowledge about how our application works in one place. And so I kind of want to push everyone here to push for methodologies that are slightly more robust against what I think of as inevitable change and necessary complexity. This complexity does not come because we're totally mismanaging things. A lot of the complexity that's increasing is because we want to build more complex things and build richer user experiences. So we need patterns that try to push back against that complexity. Thank you very much, and questions?